So I'm thinking of making a 6-inch f8 telescope, and to measure the mirror, I'm going to build a spherometer of a diameter of about 5 inches. So I cut up the aluminum bar. I think this section here is about 5.5 inches, and then this section here is about 5 inches. And then I drilled 5 holes total. One here, one here, one here, then another one on this section here, and another one down here. Those holes really don't have to be perfect. Actually, I did a pretty crappy job at it because I didn't have a workbench yet. And you can tell this one is really not centered, and neither is that one. But that's okay, as long as you make the hole for this dial indicator, and if you put it in the correct place, you'll be fine. Oh, hold on, daddy duty. Okay, so once you cut up your aluminum bars, the first thing you want to do is make the T. So you're going to put this screw to fasten the 2 bars together. So I put the screw, washer, another washer, and the nut. Once those are together, you're going to build the little legs here. So what I did was I put a nut up here with its washer. Man, my camera's terrible, sorry. And then another counter nut at the bottom with another washer and the screw. Same thing here and down here. You'll also notice this little bearing ball there, which I just glued in there with the epoxy, and it'll stay there forever pretty much. Now those little balls there are put at the bottom of the legs just to provide a point of contact with the surface of your mirror, or which is going to be the surface of a sphere. So that way you have, you guarantee you have just 3 points of contact with that surface. Okay, now that everything is installed here, what we'll want to do is actually level this spherometer as it is. Remember, we've only put the T and the legs on the T. The dial indicator is not installed yet. What you want to do now is put this on a level surface, and you'll be surprised how difficult it is to find a level surface. And then you're going to try and level this T. So what you're going to do is you're going to put a level and then just start tweaking these nuts and the counter nuts on all sides until the whole assembly is level in all directions, at least reasonably level. Okay, so next is where the problem begins. We need to calculate the radius of the circle that goes through these 3 points of contact. And the only way for me to do that is in AutoCAD, and I'll show you momentarily how to do that. Once we have the radius of the circle that goes through those 3 points, we can calculate the exact point or the center of that circle on the surface of this T assembly. And we're going to do that using the laser pointer, the piece of paper, the ketchup, the needle, and a couple of speakers I have back here. And I'll show you how to do that later. Okay, but first things first, we need to measure the distances between the 3 points of contact. So what you're going to do is you're going to grab your caliper, and you're going to measure from this point to this point, and then to this point, and then these 2 distances, or I'm sorry, this distance here between these 2 points. Once you have that, you write it down over here, and I got those 3 numbers here. Well, actually it's this one, and that one in inches. And then that's what I'm going to use to draw in CAD my spherometer, and that's coming up next. Okay, so let's calculate the diameter of our spherometer. First dimension of between the 2 legs and the common aluminum bar is 4.451, and I'm going to subtract the diameter of the bearing balls, which is 0.25 inches. They're a 1/4 inch in diameter each. each little bearing ball. So 4.451 minus a quarter inch is 4.201. So I'm going to draw here a line of that dimension up. Then the lower dimension is 4.828 minus the quarter inch again. That's 4.578, so I'm going to draw a circle here of that radius. And then the other dimension is 4.772 minus the quarter inch, 4.522, and again another circle of that radius. And that's where they all meet. Now I draw a line from here to here, and then over here. Delete that, and then I'm going to draw my ball bearings, or bearing balls. Just move them over. I'll have one there, one here, and one here. And that's our spherometer. Now what I'll do is I'll draw a circle that passes through those 3 points of contact, here, here, and here, and I'll find out its properties. And we can see that the diameter of our spherometer is 5.1295 inches, and that's the number we're going to use. Okay, so I'm going to project the points of contact of the spherometer onto a surface. And for that, I'm going to use a little bit of ketchup. So I just grab just a tiny bit and just put it on the bearing balls. As much in the middle as I can. And then I grab my spherometer and just set it on the paper. Just let it sit for a second, and then pick it up. And we have our 3 points. You can barely see them, but there's one, there's another one, and there's another one. Okay, now what I've done is I've set my caliper to the radius of the circle, which is 2.565 is the best resolution I'm going to get on this thing. And I'm going to use it to pivot around this point and just mark a circle on the paper. I'm going to put this pivot on the first point, and I'm just going to scratch the paper with this side of the caliper. And I'm going to do the same around this point and then around this other point to find the center of the circle that passes through those 3 contact points. So I'm going to do that, and I'll show you. Okay, so I've marked our 3 points a little better here. Here's one, here's the other one, that's the other point of contact, and that's the center where my scratches that I did with my caliper met, and I just marked it with a little pen. So what I'm going to do now is I'm just going to shift this over a little bit, and I'm going to poke a hole right through the middle of, in the center of the circle. And I only got 2 hands, so I got to stop. Okay, so this is my setup here. I put the 2 speakers on the side, and then I set the points of contact right on those points I marked on the paper for all 3 points. I had to put some tape on that so it doesn't screw up the setup. The dial indicator should not be here, but the idea is to put a laser pointer in that little hole we poked, and that'll mark, and you have to make sure it touches the paper, but that'll mark on the surface of the T the exact center of the circle. Okay, just to show you what the point more or less looks like, and my wife would kill me if she saw me doing this, but imagine that's your spherometer bar. Point your laser and you should see that's the point more or less. Now, to be able to mark the point with a marker on the actual aluminum bar, what I do is I cut with scissors here, paper, all the way pretty close to the point in the middle. And once I cut close to that point, I can actually get the marker from below here, and mark on the bottom of the spherometer. Now, when you drill the hole on where you're going to put the dial indicator, be sure to first use the smallest black oxide drill or drill bit you can find. That way you can be very precise in the hole location. And then once you do that, you actually turn over, once you have that little hole, turn this spherometer over and set it up again on the piece of paper. Try to match the points carefully, and then set your laser on top of this thing and see if the laser point it matches up with the center of the circle. If it does, then you're good. If it doesn't, don't worry too much about it. I'm actually off. For some reason during construction I started drilling bigger and bigger and bigger holes, and I guess it started shifting, and I'm off about 1.5 millimeters from the actual center of the circle. So it doesn't matter. I can tell CAD to pass through a point 1.5 millimeters from the center. So as far as the geometry of the sphere of the mirror, it doesn't really matter. It's going to be really precise. Thanks for watching.